You hear these terms all the time, right? AI, machine learning, deep learning. They're absolutely everywhere. But let's be honest, they're usually thrown around interchangeably, and it can get pretty confusing. So, in this explainer, we're going to cut through all that noise, decode these buzzwords, and give you a crystal clear picture of what they actually mean. So let's just dive right into the main question. What is the real difference between these three things? Are they just different names for the same concept? Spoiler alert, they're not. And figuring out how they relate to each other is really the key to understanding the technology that is changing our world as we speak. To do that, we have to start at the very beginning with the biggest, oldest idea of them all, the grand concept of artificial intelligence itself. At its heart, AI is really the big, overarching dream of making machines smart. It's a huge field that goes all the way back to the 1950s, and it's all about one goal: simulating human intelligence. Now, this doesn't always mean super complex learning. Some of the very first AI systems just followed a set of clever, pre-programmed rules to do things like mimic a conversation or play a game of chess. The goal wasn't true understanding, it was just to create the appearance of intelligence. So if AI is the big dream, where do machine learning and deep learning fit into the picture? Well, they're not separate dreams at all. Think of them as the powerful engines that actually started making that big dream a reality. Probably the easiest way to visualize this whole thing is with a set of Russian dolls. You've got artificial intelligence as the big outer doll. That's the entire field. Then you open it up, and inside you find a smaller doll, machine learning, or ML. It's a subset of AI. And then inside of that one, you've got an even smaller, more specialized doll, deep learning, or DL. Each one is a critical part of the one before it. Okay, now this is where you can really see the key differences. AI's goal is super broad. Just simulate intelligence, often with rules that humans literally write out. ML gets more specific. Its goal is to learn automatically from data. So instead of a programmer telling it exactly what to do, it finds patterns on its own. That's how your email spam filter works. And deep learning? It goes even deeper, using these complex structures called neural networks, which are kind of inspired by the human brain, to learn from just massive amounts of data. This is the magic behind how your phone can recognize your face. Right. But these ideas didn't just pop up out of nowhere. Their evolution pretty much tells the story of modern computing itself. This timeline really maps out the whole journey for us. It all started as this big philosophical question back in 1950 from Alan Turing: can machines think? The term artificial intelligence wasn't even made up until 1956. For decades, progress was marked by these huge computational feats, like IBM's Deep Blue beating a chess grandmaster. But then, everything changed in the 2010s. That was the real turning point. A massive explosion in data and super-fast processors ignited the deep learning revolution, which brings us to today, where we're wrestling with the huge role AI plays in our society. Now, let's zoom back in on that middle doll, machine learning. We keep saying it learns from data, but what does that process actually look like? I mean, really, how does a machine go from just seeing a bunch of numbers and text to actually making an intelligent prediction? It actually happens in a few pretty logical steps. First, you just feed it a ton of data. Then comes the training phase, where an algorithm sifts through all that data looking for patterns. Imagine a music app analyzing every song you've ever listened to. The algorithm then builds what's called a model. You can think of it like a little digital brain that's captured all your musical tastes. That model then gets tested on new songs to make sure it's accurate, before it's finally used in the real world to predict the next track you're absolutely gonna love. Okay, here's a really important thing to know. Not all machine learning is the same. It kind of comes in three main flavors. You've got supervised learning, which is like learning with a teacher. The data's labeled, like emails clearly marked as spam or not spam. Then there's unsupervised learning, which is more like exploring on your own. The machine finds hidden patterns without any labels, like grouping shoppers with similar buying habits. And finally, you have reinforcement learning, which is all about learning by doing, trial and error with rewards and punishments. This is exactly how AI gets so good at mastering incredibly complex games like Go. But this is about so much more than just code and algorithms. Let's look at how all this technical stuff translates into some really profound real-world consequences. Because, understanding the what is one thing, but understanding the why, well, that's everything. And this, right here, is the fundamental shift. Early AI was all about logic, about trying to hard-code human reasoning into a machine. But today's AI? It's all about learning from the vast, messy, diverse data of actual human experience. And the goal has evolved too. It's no longer just about making a factory line more efficient. It's about trying to make our world more equitable, powering tools that can give a voice to someone who can't speak, translating languages in real time to connect cultures, and creating personalized education that adapts to the needs of every single student.
This really says it all, doesn't it? The central question that's driving this entire field has fundamentally changed. It's moved from a purely technical challenge, can we build a machine that thinks, to a deeply human one. How can we use these incredibly powerful tools to empower people and build a better world?
So we've journeyed from the big idea of AI down into the learning engine of ML and right to the powerful core of DL. But this story is far, far from over. As this technology weaves itself deeper and deeper into our lives, the critical question isn't just for scientists anymore, it's for all of us. How are we going to guide its evolution to make sure it builds a truly more inclusive and fairer world for everyone? Thanks for joining this explainer.